All right, so we're gonna meet together for the last 3 questions on this exit ticket. So, here we go. Number 11, the molar mass of PbNO3 is 331.2 grams per mole. 331.2. So I know, according to the trend in this table, that that's gonna be way, way down here. Dissolving 10 grams in 0.1. These numbers are just to throw you off. If you read the passage, that's all they do is they put 10 grams into 0.1 liters. Would most likely yield a solution with a mole fraction. So I need to know what my mole fraction is. Mole fraction is X. So I'm looking at X for number 11. Would most likely be equal to. So what's the trend here? It's going down, and then we need to go down again, and we need to go way, way down here. So we're at about 0.009. 0.008 is too close, 0.011 and 0.014. These are too large. So we're between A and B. These are our two best. Now 0.008 is only like 1 difference off. And if you'll see, these go by about 1 on the last 3. But these, that's about a difference of 40. So 40 would get you 0.1. And this is a difference of more than 100. So because difference in molar mass is so large, we need to decrease most. All right, number 12. A mixture containing 100 parts of finely ground rock samples from location 2 and 8 parts of H2O was heated to 1400 degrees Celsius. So we're looking at the 1400. Which of the following is an accurate prediction of the mixture's velocity? So location 2, 100 parts of finely ground, 1400. So what's an accurate prediction of the velocity? At location 2, what does this table say? So we have our locations, which emits a characteristic determined. Okay. So 8 parts H2O, we want to see the percent at 1400. Let's just read over here. Okay, so 100 just means that these are going to be our percents at location 2. So we'll look for these, and then we'll go to the graph, and we'll look for our 1400. So that would be 13, 14, and so on. Now, we need to look at these locations. So what would be the accurate one for the middle line? Middle line, middle line, middle line, middle line, and viscosity. Oh, I was saying velocity. So, what would be the accurate one? So if we go to the middle line here, and we're looking at these amounts. For the 1400 line, that's about 180. If we're looking at all the lines, and you just trace the middle line, we need to look. And the answer there is going to be D, because you trace the middle lines and see how it changes. And all of them were around above that. Which of the following temperatures is most likely to produce a viscosity with 25 for a sample with 6 parts per 100 of FeO? So, FeO right here, 10, 10, 5, so 6 is going to be about location 3, and then we need to see the temperatures here. So for 13, looking at the graph, and again of FeO, parts per 100 is 6 on this graph. So, and we want the, so we're looking at the 4th line on the graph, and then 25. So 25 is going to be low. So where will it be the lowest? What temperature? I'm going to trace my FeO line into the pattern that they're going. So what would that be? It's going to be on the outside of the graph, and according to that temperature, it goes as it goes down, or it goes up as the temperature goes up. So as the temperature goes up, the viscosity goes down. viscosity with temperature. So we're going to pick the highest temperature. So for that one, you found the trend on the graph. And I know that one is a little bit hard to see, so if you miss those, don't worry about it. I mean, you'll still correct them, but you can say I couldn't see the numbers on the graph.